Right, so welcome to the computer science lesson on sound in computers. So in this lesson, we're going to learn how does a computer turn analog sound that we hear into digital sound for the computer. So we're going to look at two terms. We're going to look at sample frequency and bit depth, and I'm going to go through them in great detail so you understand exactly how they are used. So these are the two keywords. So sample rate is basically how many samples a second of audio the computer takes. And bit depth is about how many bits it allocates to each sample, improving the accuracy. At this time, you might not know what that means, but we're going to go through those in a second. So first off, I'll look at sample rate. So sample rate is how many samples or measurements of the sound are taken each second. So before we do that, let's go over to my diagram and explain it all. So this is a sound wave. Okay, I hope you understand that that's what sound looks like in the air, or is like in the air. But these are vibrations of atoms in the air. So the air is vibrating like this, and your ear picks it up. So what we need to do is turn those vibrations into numbers. So here's how we do it. First of all, what the computer does is it selects a sample rate, because basically it's going to take a measurement of this wave a certain number of times a second. So let's take a reasonably high sample rate. Okay, so put it on. So the computer's decided it's going to take, let's say this was 1 second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 in a second. That would be a terribly slow sample rate. Sample rates are normally like 44,000, but this one's going to be 16. Okay, but you get the gist of it. So we're going to take 16 in this 1 second of audio. So what's going to happen is, then what the computer will do is for every time there's a sample, it will see how high this is. And so you understand what it will do, but we'll talk about more of this with bit depth, is it will put a number at the top, say 127. It will put a number at the bottom, minus 128. And then that will be the top number and the bottom number. And so that would be roughly 127, or the top would be, and that would be roughly, I don't know, 70 or whatever. But I'm not going to quite go through the numbering of it at this second. So, because we've got about sample rate, their numbering's to do with bit depth. So if you see here, we take a sample and we put a dot. Then what the computer basically does, it joins those dots to form its own version of the wave. Okay? But now if we take the original away, you can see that it's not exactly perfect. Okay? It's obviously lost this little curve here. It's lost quite a bit of data. If we go back to the original, you can see the curve. If you take it off, the curve's gone. Okay, but this is with a reasonably good bit rate in sample rate, in our little made up example. What if I had an even lower sample rate? Okay, so let's turn off the high one and start with the low ones. This time we decided to take only 2, 4, 6, 8, 9 samples. Okay, so once again, that'd still be 128 minus 127. So once again, we put dots where the samples are. Okay, then we join them up with lines. And as you can see here, I don't have to take this one off so much this time because it's so not close to the original. You can clearly see that we've lost quite a lot of the accuracy of the sound. And so the sample rate is really important to how accurate the sound is. The more samples we take per second, the closer to the original. If I had lines, like thousands of them here, and started drawing little lines here, you'd barely even notice the curve. Which is in essence what they do with 44,000 a second. But it still does make a difference even at 44,000 a second. You might say to yourself, why don't you just do more? Well, you don't get anything for free in life. The more samples you take, the larger the file size, the more processing power required to record the samples and play the samples. And often, most people wouldn't notice a difference above, say, 44,000, although some people do, me not so much. So just so we get out, the sample rate is how many samples or measurements of the sound are taken each second. The more samples taken, the more detail about the waves are kept, but then, obviously, there's bigger file size. So now I'm going to go through and explain what bit depth is, and it's always best explained using an example. So I'm going to start with the example and come back to this. So let's go to this. Let's turn off all this and get ready to my low one. Okay, so I'm going to explain this first. The red line is like before, that's our sample rate. So every time there's a red line is when the computer's going to take a sample. Now before, what we were able to do, I'm just going to draw a green circle there, ready to be able to move it around. was put, if we wanted a sample, let's take this one, we would just put them wherever they crossed over like that. Okay, like that would go there, that would go there, that would go there. But what we have to do now is, because bit depth is in play, computers have to have a degree of accuracy. So here, I have to put it on one of these black lines. This has got a very low quality of bit depth. There's not a lot of options. So I can start, that one is bang on 0, okay? When I put the next one in, yeah, that's brilliant. That red line and black line are right on top of each other, fantastic. But here, whereas I want to put it there, because that's where the black line, they cross here, I can't. I have to put it on a black line, the closest one. And the same here, look, I'd want to put it there, but I can't. So I have to make a decision. I'd say it goes down to this one. So now it's gone down to there. And this continues. I want to put it there, but I'll have to put it right on the line. And this carries on. Like, this one's not very good. Look, it crosses over here. So I'm going to have to put it there. And the same here. It's going to have to go on the black line. That one's also going to have to go on that black line. This one here, that's the worst situation. It's right in between. I'm saying it's still lower, probably. The next red line there, maybe. And the next red line is right in the middle again. So that's going to go up. That one probably is closest to the top. That one's closest to there. And that one is closest to there. So, delete that one. And now what I do is draw a line in between like before. So I'm going to draw, let's go purple, why not? If in doubt, purple. So I'm going to draw a line between the whole thing, between every single one. And as you can see, I've once again lost accuracy from the original. So that is not that much like that. And so bit depth affects how accurate the sample is as well. So how many samples we take and how accurate each sample was. If, for example, I had a much higher sample rate, bit depth, and the same sample rate, you can see that because I have when I'm in between one, it's going to be smaller because the gaps between them are smaller. So last time I was moving, say, from like here all the way up. Now I'm just moving, say, from there down. And as you can see, if I was going to draw this one, which is exactly the same sample rate but with a different bit depth, they're actually a lot closer to the original. I'm going to make that blue, and then I'm going to take everything else off except, let's just take that line because I drew it on the wrong layer, put it on this layer, and then if I compare the low and the high, you can see that clearly that looks more like a curve, that looks more like the original. So when there's a higher bit depth, it's more accurate to the actual original sample, okay? So, but once again, a higher bit depth means more memory, okay? If you're only using 8 bits, which is 1 byte, to store each sample, then 100 samples takes 100 bytes. If you're using 2 bytes to take each sample, then 100 samples are 200 bytes. So increasing the bit depth also increases the file size. So just as a thing now, I'm going to play you some audio of Adele's Hello that shows you the difference between it. Now I am recording it, so I'm hoping this won't sound too bad. So this one is pretty much top everything. That's a high, we're talking about real high now. That is proper CD quality, sort of 44,000 hertz and 32 bit depth. Okay, so it's a high bit depth, high sample rate. I'll play a little bit.
Hello, it's me.
Obviously it's been recorded.
I was wondering if after all these years you'd like to meet.
Okay, so that's high sample rate. Now let's play a low bit depth, but a high sample rate. So this is going to show you just what bit depth does, because they both affect quality in different ways. One makes it noisy, one smudges it slightly. So you'll see this is bit depth.
Hello, it's me. I was wondering if after all these years you'd like to meet.
Now I don't know if that was picked up on the microphone because I'm recording it, but basically a lower bit depth adds like a hissing noise in the background. So it's like shh, especially when there's no audio playing. So bit depth really adds this kind of like noise to it, like wind or hissing. Let's do low sample rate, but high bit depth.
Hello, it's me. I was wondering if after all these years you'd like to me.
So that, in my head, how I talk about that is I find that sort of smudgy is the sound. It sounds a bit like they're in a room and you're listening to it outside the room. Like it isn't clear across all the tones and the pitches. It's like smudged. This is the worst of both situations, low bit rate, low sample rate, and it'll just sound very bad.
Hello, it's me. I was wondering if after all these years you'd like to me.
And as you can hear there, hopefully on the audio, that it's bad quality and hissing. And underneath you've got the file sizes. So you can clearly see that obviously the best of the best, it's bigger file size. I mean, that's a very small clip, just to clarify. It's only 11 seconds and it's 4 meg. But there is compression that you can do on these things, just to be clear, to make that smaller. So don't just go by these sizes, but it does give you an understanding of the difference. So hopefully you've got an understanding of what sample rate and bit depth do. So I'm going to explain in the next part of the video how to do the work. So I'll see you then. Hi, so if you're in school and you have access to your booklet, the little starter task here that you might have already done or might be doing now is just trying to get across with a bit more. Actually, this actually demonstrates a bit better this waveform than the one I did in the video possibly, because it's more accurate to a waveform, much more jittery and all over the place. And so what I want you to do here is draw yourself obviously in with a pen, draw where it crosses, okay, or where it crosses over, where the lines cross. And then I want you to guess what you think each number might be. Obviously, I'm not going to do too many of them, but maybe that's minus 45, maybe, which is maybe minus 50. It's maybe 40. 20, whatever you think, they are. And then you can draw lines between each one to demonstrate what it looks like. And the reason for this is not just to randomly do it, but it's to demonstrate to you about the loss of data as you turn something from analog into digital. There's always a loss, and as you can see here, we're losing every bit of this wave under here. It's getting simplified, and that affects the audio. Okay, so if you're in school, then that's one part of the work to do. If you're at home doing this, or it's homeschool, then you might have been given this worksheet to complete. So there you have to go on the internet, or describe it in your own words. We don't only copy and paste it, because you're not going to learn it if you copy and paste it. I'd much rather one short sentence that's in your English than copied and pasted rubbish. What is meant by the term sample rate? You say something on the lines of sample rate is about how many samples are taken per second on the computer. They're measured in hertz, which is abbreviated to HZ, which actually just means per second. You'll see it a lot in audio and a lot in other things in computing. But you can get maybe some pictures in there as well at the bottom here. Draw some pictures or get some pictures. Okay, and then you can calculate the file sizes. The math is quite easy. You multiply the sample rate by the bit depth by the number of seconds. So it's just times, times, times. And that will tell you a rough idea of the file size. It's not always exactly accurate, but it's close enough. And then I want you to find some audio formats online. It's quite an easy piece of work for you to complete. If you finish that, you may, or if you've been given different work, you may have been given this work to do. If you've been given this work to do, then it's just a similar thing, but obviously slightly simpler version of it, where you don't have to do some of the other parts to the piece of work. You just describe what is meant by sample rate, bit depth, and you draw associated images. So it depends on what work you've been given. Normally we do this in class, if you've got a shorter lesson maybe, because we haven't got time. But yes, you won't probably be doing the booklet work. You might be given the longer and more advanced vision map, I call them really, or squares they're normally called, to do.